Hello, this is our first lesson on our next topic, which is algebraic expressions, term combining. So with this first lesson, we're going to have to talk about many new vocabulary terms. And so we're going to get started today, and then we're going to hopefully have some examples that provide greater understanding of that. Here are 6 words you need to understand the meaning of when we're working in this unit. So the first one is coefficient, constant, like terms, polynomial, terms, and variable. They've been listed in alphabetical order, not necessarily in the order that we're going to write them. So the first one says, a symbol, usually an alphabet letter, used to represent an unknown quantity, a number, is called a variable. So you're noticing it says it's a symbol, usually an alphabet letter, and it represents an unknown quantity. So we're asked to circle the variables in each expression. So we're looking for an alphabet letter. And so this first expression says 7x minus 4. So the alphabet letter, or the variable that we see, is x. This next one, I see 3a squared plus b. And even though the a has a little 2 or an exponent on it, it is a variable. So we're going to circle the a, and we're going to circle the b. Please try C on your own and tell me what the variable or variables you think are. If you said x and y, you're correct. Now let's go on to our next definition. A number used to multiply a variable is called a coefficient. And the word coefficient, if you notice this word co, like a coworker is somebody that you work together with. And that's exactly what happens. It's a number that works with a variable. So it's very important that you know the number goes with the variable. So let's go ahead and put an arc there. This number and this variable are attached to each other through multiplication. So if I look at this 7 is attached to the x, and it actually means 7 times x. Remember, side by side means multiply, but the coefficient is the number, 7. 4 is not a coefficient because it's not working with a variable. In our next example, 3 is a coefficient because it's a number working with a variable. But we're going to notice that b is not with a number. However, any plain variable, a variable that's by itself, we can always write the number 1 in front of it. So 1 times b would be b, just like 1 times 8 is 8, 1 times 12 is 12. Well, 1 times b is b. So actually, this has a coefficient of 1. So look at example C, and please tell me if you can find a coefficient or more than one coefficient. If you said 4 is a coefficient, you're correct. If you said 8 is a coefficient, you're correct. But unfortunately, 2 does not get to be a coefficient because there's no variable here. So it is just 4 and 8. So let's go to our next definition. A number that stands alone in an expression is called a constant. It goes on to say it has a fixed value, so a constant. And by fixed value, it means its value is not going to change. The value of this expression, or this term, is going to change based on what x is. It's variable, it varies. But a constant is exactly what we see as given, the number. So it asks us now to circle the constant in the expression. So we're going to circle the constants in each expression. So when I look at this first one, 7 is a coefficient, a coworker with a variable. So 7 is not a constant, but 4 is. And later on, we're going to talk about the sign in front of it. So we are going to circle the 4. In fact, right now I'm going to have you circle that -4 in front of it. We'll talk about that at a later date. Let's go on to the next expression. 3, I see that as a number, and it did say it's a number, but it stands alone. So this 3 is working a coworker with that a squared. So it is not a constant. And if I look at b, it's a variable, and I don't know what the value of it is. So it doesn't have a fixed value. I don't know what the value is. So in this expression, there's no constant. Now let's look at C. I'd like you to try C on your own. Can you tell me if there's a constant, no constant, or more than one constant? In this example, 4 is working with x. 4 is a coefficient. 8 is working with y. 8 is a coefficient. But 2 is a constant. It doesn't have a variable with it. It's a fixed value. So we're going to go ahead and circle 2. And you're going to notice I circled that minus sign in front of it. Again, we'll talk about that later. Please turn to the back page. Moving on forward, a term. So let's go ahead and write that word right away. A term in an expression can be a number, a variable, or the product of a number and variable. So a number, it could be a variable. So this would be a number. This could be a variable like n, or the product, meaning I'm going to multiply of a number and variable. So we could write this as -3a. So that's a number and a variable, and we're multiplying. Side by side means multiply. This is very important. Terms are separated by plus and minus signs. So even though my brain sees two things here, this is one term. One term. So we're going to be asked how many terms are in the following expressions. So let's recall it said that the terms are separated by plus and minus signs. And when we circle these terms, I'm going to ask you to use the sign, the operation sign, the plus or minus sign, in front of each term and have it go with the terms. For example, this is one term. This -9 is one term. And here's a plus sign, and I see plus n. So they have a number. This is a second term. I'm going to take that plus sign with the n, always the sign in front of it. So I have a number, a variable, and now I have a third term, which is the product of a number and variable. So 1, 2, 3. This expression has 3 terms. Let's look at example E. I see 4x. Remember, the product of a number and a variable hooked together is one term. Then I see +4, so I'm going to take the plus sign with it. So that's my second term. This is 1, 2. So there are 2 terms. Please tell me how many terms are in example F. If you said 4 terms, you are correct. There's 5a squared. It's okay to have an exponent. There is plus 2a. There is -6. And there is 7a. So 1, 2, 3, 4, 4 terms all together. So moving forward, we're going to write like terms right here. So like terms. So the word like implies that something's similar. So like terms have the same variable raised to the same power. And a power is an exponent, that little number. The coefficients can be different numbers. We choose to combine or put together like terms, and that's what we're going to do in this next chapter. We're going to put them together, called Combinig, in order to simplify or shorten an expression. So we're going to start with example D. We're looking for something that has the same variable as long as it's raised to the same power. So looking at D, I see -9, I see an n, and I see -8n or -8n. So it turns out that this term, and let's go ahead and use my pen, that will be helpful. This term has an n, even though it doesn't have a number in front of it, and this term also has an n. So it doesn't matter what's in front of the n, but they both have the same variable. Looking at E, I see 4x plus 4. Now I'm really tempted to say that these are like terms because of the 4. However, the definition says something about having the same variable raised to the same power. And I see a variable here, but I don't see a variable here. So these are not like terms. If I would have had, let's say this for instance, if I would have had this example, if I had 4x and 3x, these are like terms because of the x. But if I would have had 3a and 3x, they're not like terms. Because they have the 3, it's the variable that we're looking at. So please try letter F and tell me if you see any like terms here. If you said that 2a and -7a are like terms, you are correct. And that's because they have an a. So some of you might have wondered if this was a like term because we see a, but because of this little exponent, it's not a like term. It's only a and a, but the minute we put this little exponent on it, even though it's over the a, it doesn't get to be a like term. Okay, so let's try to finish this up. These are words you might hear during this chapter, and this is a fabulous word. A poly, which means many, nomial, many terms, is an expression that contains one or more terms. There are 3 special names that we give frequently seen polynomials to help us identify the number of terms. The first one is a monomial. Would you please circle that mono? And if you've ever played Monopoly, that means one player is trying to win all the properties. So what that means is we're going to see one term. An example of this might be 3xy. Now that looks like it's more than just one, but there's no separation with plus and minus signs. They're all a product. So monomial has one term. Next, you're going to notice the prefix bi. A bicycle has 2 wheels, so binomial has 2 terms. And we have to separate our terms with plus and minus signs. So if I had 4x squared plus 2y, we now have 2 terms. And finally, tri, like a tricycle has 3 wheels, so a trinomial has 3 terms. And these are frequently seen. We might, for instance, have 3a squared plus 2a minus 1. So 1 term, separation with the plus, 2 terms, separation with the minus, 3 terms. So that I can check for understanding, would you please choose one of these three, monomial 1 term, binomial 2 terms, or trinomial 3 terms? Would you write one of these on your own? Thank you so much for going through this vocabulary sheet. Once we start term combining, we're going to have a lot of fun. It's a fun chapter. Bye-bye.